Kirkwood Math. Hello and welcome to Module 9. Here we go, starting our pre-algebra work. So we're starting to learn the information that you're going to need in order to do algebra, and algebra is going to be a focus 7th grade, 8th grade, high school, and beyond. So we're learning these key foundational skills. All right, so our first lesson is focused on expressions and equations, and specifically exponents. So our objective today, when you're done with this lesson, is you should be able to write and explain the evaluation of expressions with whole number exponents. So if we were doing this in class, you would be turning and talking about this. But for right now, go ahead and just write down how many different ways you can show the number 4. Okay, so you're going to be really creative and try to find as many ways as you can. For example, I could write the number 2 as 1 plus 1, or as 10 divided by 5. There's lots of different ways that I could write the number 2, but for you guys, think about the ways to write the number 4. Pause the video here and write down some ways, and then come and join me and we will go over a couple ways that I'm thinking of. All right, so hopefully you've paused your video so that you can think about this. Let me just get my drawing up. All right, so some ideas that you may have thought of would be 4 times 1, or 16 divided by 4. Nope, divided by 2. Sorry. You could have done 8 take away 4, or the square root of 16. No, it is. Nope, I had that right. Sorry. Various things here. 3 plus 1, lots of different ways. No matter what you wrote down, as long as it equals 4, you are correct. And what we wrote down, all of these, plus the ones that you may have thought of, are called equivalent expressions, because they are all math problems that express the same answer. Okay? And that leads us into some of our vocabulary here. So we have the difference between an expression and an equation. Okay, so an expression is a mathematical phrase that contains operations, numbers, and or variables. Variables are our letters, our X, Y, A, B. We haven't learned too much about those letters, but that's what an expression can include. An equation is a mathematical sentence that shows that two expressions are equivalent to each other. So equations show two expressions, and they have to have an equal sign in the middle. You can see here in our example that every single one of these equations have an equal sign, whereas the expressions do not. Okay? We also know from the definition that this, in an equation, this is an expression and this is an expression, and they are the same. They are equal to each other. So if I knew what y was, if I solved this, it would turn into 8 as well. Okay, so right now I want you to write down in your notes the difference between an expression and an equation. You get to decide what is important of the information on the screen. You can summarize, you can write down our table here, just be detailed so that when you go back and look at this later, you understand the difference between an expression and an equation, and you don't just have a 1-word or 2-word answer. All right, the next 2 vocabulary words are equivalent expressions and equal signs. We know that an equivalent expressions are 2 expressions that have the same value for all values of the variable. And basically, it means that whatever is over here is the same as whatever is over here. These 2 things have the same value. And if there are any x's or y's, then it is the same value as this x on this side or this y on this side. Those would be the same values. An equal sign, now you may think, Ms. Kirkwood, I already know what an equal sign means, but the nice thing about an equal sign is that in elementary school, you kind of learned like 3 + 1 is 4. And you may think that equal means is, but that is not true. It means is the same as. So I'm saying that this expression on the left is the same as this expression in the right. And really what you were doing in elementary school was writing equivalent expressions, and you just didn't know it. So here are some examples of what an equal sign means, and showing you different ways of like showing that that's the same number versus kind of a traditional math problem versus an equivalent expressions. So please write down these definitions, the definition of equivalent expressions and what an equal sign means. And then we're going to get ready for our next set of vocab words. All right, in this one, we are going to write down the information about this specific type of expression and with exponents, okay? So this is a mathematical expression that can be solved. I can solve it to make an equivalent expression here, which we call expanded form because it's expanded out. And then we have our standard form answer here, which is our solution. So in this particular type of problem is called a power. The whole thing, 2 to the second power, is called a power. It is also an expression. That means that it is a math problem, really. So if you see something on your paper like this, you can put an equal sign and find an equivalent response there, equivalent value. You can solve it. Okay. Inside of our power, we have this part here, this big part, we would call the base. And then this little part right here, we call an exponent. Our base, we also use as our factor. It's the number that we are going to multiply over and over and over again. And you can see that here in number 4, because the 2's are also our factors. So this base is the number I'm multiplying, and then the little number is not what I'm multiplying by. That is how many times I multiply. So that little number right there, that exponent, is going to tell you how many times you're going to multiply your factor, which in this case is 2. So 2 to the third power would be 3 2's multiplied together. 2 to the fourth power is 4 2's multiplied together. And I can use the little x's or I can use dots to mean multiplication. All right, make sure you write that down. Here it is, written a little bit nicer, so you can see it's not just my handwriting. Again, pause the video at any moment if you need extra time to write things down. Otherwise, we're going to move on to filling this in. So again, if we were in class, I would have you talk to a partner about what goes inside these blanks. But if you want to go ahead and pause the video and try to figure out what we would do to fill in all of these blanks here, looking for patterns and using the information we just learned about what a base does and what an exponent does, see if you can fill in these blanks. All right, hopefully you paused to think about that for a minute, but we're going to go ahead and fill them in. You may have started to see a pattern. So 4 is my factor. It's the number I'm going to multiply, and the exponent 2 tells me how many. So there are 2 4's. 4 times 4 is 16. 4 to the third means I'm going to have 3 4's. That becomes 4 times 4, which is 16, and then times another 4, and that's how we get 64. 4 to the fourth power is going to be 4 times 4 times 4 times 4, and that, my friends, is going to be 64 times 4. So I'm going to get 200 and something, 56. Then down here, I'm going to have 5 4s. So 4 times 4 times 4 times 4 times 4. And I'm going to get 256 times 4, which is 1,000. And I think 24, if I remember correctly. Let's see. That's right. Now, you may have noticed that every time I move down, I'm multiplying by another 4 in my table. And that is the same every time. If I went down again, I would be doing 4 to the 6th, and I would have 6 4s, and I would multiply 1,024 by 4. Now, the same is true about going the other way, but opposite. If let me switch some colors here. If I start going backwards, going up, instead of multiplying by 4, I'm going to divide by 4. 256 divided by 4 is 64, which means 64 divided by 4 is 16. And that means I can find the value of 4 to the first power by dividing by 4. So 16 divided by 4 is just 4. Then if I look in this pattern, 4 to the second power means there's 2 4s being multiplied. 4 to the third power means there's 3 4s being multiplied. Then 4 to the first power means that there's just one singular 4, and it's not being multiplied by anything. Okay, so again, I'm going to show this to you a little bit more organized. And remember, our patterns that we saw was this is dividing by 4, whereas moving down is timesing by 4. And now we just have this pesky little piece here, this guy right here, that we have to figure out what it is. Well, if I look at the pattern going up, I can see that I'm getting smaller and smaller with my exponents. We're going down one, right? 4 to the third, 4 to the second, 4 to the first. So that means this power should be 4 to the 0. And that would be correct. But how would I know what its value is? Well, if I continue this pattern where if I move up, I divide by 4, then I should be able to divide 4 divided by 4. And that gets the answer of 1. Anything raised to the power of 0 is 1. And there's no real expression. We're not going to fill in anything here, except you could write the property name, because there's no expression that goes with it. There is something that you learn in 8th grade, but I will save off on showing that to you because this explains it better right now. We know that anytime I increase by an exponent, I'm really multiplying and by that base. And if I decrease in an exponent, I'm really dividing by that base. So it makes sense that 4 to the first power is 4, so 4 to the 0 power would be 4 divided by 4, which is 1. And that's always how it's going to be. So on your notes, you're going to go ahead and write this down right here. Any exponent raised to the power of 0 is always 1. And that, my friends, we call the property of 0. So if you are ever told what number is raised to the power of 0, you can just recall that it's because of the property of 0, it's just 1. Or you can remember that it's because we're dividing by that base, so that's going to turn into a 1. Let's write that down. And then the next thing we're going to write down is going to be reminding ourselves that anything raised to the power of 1 is itself. That is an identity property. Because it identifies as itself, it's going to become itself. So anything to the power of 1 is going to be itself. So you're going to write this down in your notes as well. And that is where we're going to pause for right now. So this lesson is a lot of notes. It's a lot of new information because we are learning our algebra, and that is a new piece of information for us. So we have to recall different vocabulary words or learn new things so that as we talk about algebra, and I use words like expression and value and power, you know what I mean. And it makes it a lot easier to learn. So we're going to pause our video here. And then you can join me in the next video so that we can actually start practicing solving problems with exponents, as well as learn a couple special exponents as well.